right, so as we look at this problem, we have a compound event problem. We have flipping a coin and a number line. So I've drawn the tree diagram here with event 1 and event 2. And that kind of helps us figure out how many total possibilities there are. We can count that there are a total of 12 possibilities, which means the probability of each event is 1 out of 12. So we can go ahead and calculate that out. And we're going to get 0.083 repeating. And so we move the decimal 2 times, that's going to be 8.3%. So that's our the probability of each outcome in the sample space. This is answer to question A, along with the sample space, 8.3%. It says, what is the probability of getting heads on a coin and a number 3 on the number cube? So again, there are 12 total possibilities. In this case, this is the only event that meets that criteria. So it also has a 1 out of 12, which means we also know that this is going to be 8.3%. And finally, it says, what is the probability of getting tails on the coin and an even number on the cube? So for this one, tails 2, tails 4, and tails 6 all meet the criteria. So our probability for that would be 3 out of the 12 outcomes, which would be 0.25 or 25%. All right, let's flip on over and look at our aim for today. All right. Today's aim, Kipsters will be able to find combined probability of outcomes. So looking at our aim, when we think about this, I call them combined outcomes. That should make us think pretty quickly that the probability of combined outcomes would be combined. So if we're given the probability of 2 particular events, then we would expect that if we combine those 2 probabilities, we're going to get the probability of both of those events possibly occurring. So this is not the scenario where we have 2 events and we're saying, well, it's going to be this and this. This is a scenario where we're saying, hey, you know what? Both of these would be okay. So when we look at this first example, it says Jenna goes to the farmer's market to buy bananas. The number of bananas she might buy and their probabilities are listed on the table below. So in a single event, or a single occurrence, she has a probability of 0.1, which we can rewrite as 10% if we want. And we can go through and do that for all of them because I like percents a lot better. They are more meaningful to me than decimals. And it says, what is the probability that Jenna buys exactly 3 bananas? Well, that's only one of these possible outcomes, which is exactly 3. So when we look at this one, this probability off of the table we can read is 20%. Now when we come down and look at the probability that she doesn't buy any bananas, again, that's a single one of these outcomes that meets this criteria. That's going to be 10%. As we scroll through and we look at it, it says, what is the probability that buys more than 3 bananas? So we've actually seen a lot of this already. We've seen number cubes where we would try and get more than 3 on a number cube. And so we'd say our possible outcomes were 4, 5, or 6. And so essentially, we were thinking about those one outcome at a time. In a lot of ways, what we actually did is we added 1 out of 6, 1 out of 6, and 1 out of 6. And so what we're looking here is the same idea, is we can add these probabilities together for these unequally likely events to find our total probability. So it says more than 3. That's not going to include 3. So looking at this, we're talking about the probabilities of 4 and 5 bananas. And when we add those together, that's going to be 20% plus 30%, and that's going to be 50%. What is the probability that she buys at least 3 bananas? And so that's that language that we've seen before, at least 3. That is inclusive of 3. 3 or more would be another way to say this. So when we come over here and we look at this, now we can include this 20% as part of our work. And so it's 20% plus 20% plus 30%. And that would give me 70%. What is the probability that she doesn't buy exactly 3 bananas? So basically we're trying to use everything except for we're excluding her buying 3 bananas. So a lot of this, what we can see here is that we need to be super careful about what we're reading. And that, like I said yesterday, is probably going to be one of the keys. So not 3 exactly. She's not buying 3, so that would include my probability of 0, 1, 2, 4, or 5. Now, there's really 2 ways to think about this. One way we think about it is we notice the total probability of all events is going to be 100%. And so for me, it's easier to say, well, I have 100%, but the one that I'm taking out, the probability I'm taking out would be the probability of the 0.2. So I could say that this is 100% minus the probability of getting exactly 3 bananas would give me 80%. Now, equivalently, we can add up all the probabilities of everything else, but this is going to be a really important skill, being able to think about it the other way. So I could add it up as 10% for the 0 bananas, 10% for the 1 banana, 10% for the 2 bananas, and 20 and 30% for that. So we look, and that would also give me a total of 80%. Doing it this way is going to be a huge time saver, and actually is an important concept that we're thinking about. When we're looking for the probability that we don't get something, we can always think about it as 100% minus the probability of that. So we're actually going to write this down really quickly. P of the probability of not, we'll just say X, would be equal to 1 minus the probability of X. And so basically that's what that's saying here. So we go back and we look at what we did. This would be the probability of 3 bananas was equal to the 1 or 100%, since we did percents here, minus the probability. Sorry, going back to this. This is the probability of not 3. The probability of 3. And that's where we got the 100% minus the 20%. And that gave us the 80%. So again, if we want to find the probability of not something, we can always find it by saying it's 100% minus the probability that that event actually does occur. All right, on a given day, find the probability that Rick eats these particular things. Actually, I want you to go ahead and go through the entire problem here, parts 1 and parts 2 of this particular problem, then come back and check in. All right, so looking at this here, it says 2 servings of fruits and vegetables. So that's going to be here. That's just reading directly off. This is 28%. There's a 28% chance. More than 2 servings of fruits and vegetables. So that's what I've circled here in blue. That's 39% plus 12% would be 51%. At least 2 servings. Again, that's that language, at least 2 servings. That's inclusive. So basically, I'm taking what I previously had there, 39 plus 12 plus the 28. And that's going to give me 63%. Now it says find the probability that he does not eat exactly 2 servings. So this is that idea. We can say the probability of not to is the same thing as 100% minus the probability of 2. All right, that's one way to do it. Otherwise, if we're thinking about this in the real world, we may have a list of things that has a probability. The outcomes may be 20, 30 outcomes, and it would be really, really painstaking to go through and add up all of the other 29 things. And for this one, it may be easier to go ahead and just subtract it. It's going to save us a lot of time. So we have 100% minus the probability of exactly 2 servings, which we come back, we've seen that several times here, is 28%. So minus 28%. So the probability of them not getting exactly 2 would be 72%. All right, moving over here, it says Luis works in an office and the phone rings occasionally. The possible number of phone calls he receives in an afternoon and the probabilities are given in the table below. Now, we see here that this is all in fractions. There are a couple of different ways that we can deal with this. We can change them into decimals and percents, or we can just leave the probabilities and do them with fractions. It's really up to you. Now, the problem with changing the decimals and percents, particularly in this case, is that we would end up with repeating decimal results. And we'd end up having to round our solution. So just realize that that's a caveat depending on how accurate you need to be. So I'm just going to think through this, and I'm going to think through it in terms of a rounded example. I'm going to take this as 1/6. 1/6, which is approximately 16.7%. 16.7%. And here I add them up, 2 out of 9. That's going to be approximately 22.2%. 1/3 is going to be approximately 33%, and 1/9 is going to be approximately 11.1%. Now, one thing that we're going to recognize here is if we go through and we add all of these up, we may not get exactly 100%, because when I went through here, I had to round things, and depending on how things ended up needing to be round, they may or may not end up. So they could be, 0.1, 0.2% off. And so we know that every calculation we use with these numbers afterwards is inherently inaccurate. So that's one reason why people might stick with the fractions here. It says find the probability that Luis receives 3 or 4 phone calls. So looking at the probability of these two combined, so that's 33.3 based on how I rounded them, or 11.1. Which would be 44.4%. And if we wanted to do this with fractions, we'd have 1/3 plus 1/9, which would be 3/9 plus 1/9, which is 4/9. And actually, if we go through, we'd find out that 4/9 is equal to 49.4 repeating percent. So again, that's 2 different ways to do it. This one is technically more accurate. Find the probability Lee receives fewer than 2 phone calls. Go ahead and finish up these last 3 questions on your own and then come back and check in. All right, here we are, fewer than 2 phone calls. That's going to be those 2 combined, which is going to give me 33.4%. And this is where we're going to see some inaccuracy here by using those. We have 1/6 plus 1/6 would be equal to 2/6, which is 1/3, which we know would be 33.3%. So there we go. We can see some of the inaccuracies that are created by using these rounded values. Find the probability that Luis receives 2 or fewer phone calls. So when we look at this, 2 or fewer, that does include now the 2. So we could add the 2/9 in there, so 22.2%. So it's 33.4 from the earlier 16.7 plus 16.7 plus 22.2. And that's going to give me 55.6%. Again, I can tell you this is going to be a little bit off in terms of its accuracy just because of the rounding. Finally, it says find the probability that Luis does not receive 4 phone calls. Again, this is a probability of not, so the probability of not 4 is the same thing as 1 minus the probability of 4. So probability of 4 phone calls is 11.1%, or do this in percents. 100% minus 11.1 is going to give me 88.9%. All right, let's go ahead and flip on over to the other side. All right, so on this side, before we get going, go ahead and answer all of question 6 on your own, and then we'll check back in. So we had a couple different methods you could have gone about doing this. You could have changed them all to percents first, or you can deal with them in fractions. Again, remember the fractions is going to be perfectly accurate, whereas the percentages is going to require you probably some rounding and therefore make things somewhat inaccurate. So realize that you have those choices to make as you go through this particular problem. All right, so this, if I change these to percents, this would be 8.3%. The 1/6, we've already seen that before today, that's the 16.7%. The 5/12 is going to be 41.7%. So actually I'm going to have to start writing sideways because there's just not enough space here. 41.7%. This is 25%, and the 8.3%. Again, we know that those are rounded numbers, so this is not perfectly accurate, so we do need to be careful of that. Buys 3 heads of broccoli. All right, so that's exactly the 25%. That's that single outcome. Does not buy exactly 3 heads of broccoli. So this is the probability of not 3. So that's 100% minus the probability of 3 heads. That's the fastest way to do this. Again, you can add up everything else. That'd be 100 minus 25%, which would be 75%. Buys more than 1 head of broccoli. There's a couple different ways to think about this one. You can add up the 3 pieces, or you can subtract 0 and 1 from 100%. I would say for me, I'm going to go ahead and just add them. 41.7 plus 25% plus 8.3%, and that's going to give me 75%. Probably that buys at least 3 heads of broccoli. Remember, that does include the 3, at least 3 or more. And that's going to give me, when I sum up the value of these 2 up here, 25% plus 8.3% is going to be 33.3%. All right, let's flip on over here. It says the diagram below is a spinner. It says the sections of the spinner are colored, and we want to figure out what the probability is. So, when we're thinking about this, remember we're thinking about the fraction of the clock that the spinner can land in, and that's going to help us determine our probability. So we know this clock is initially broken up into how many different pieces? Should be thinking to yourself, well, it's broken up into 12 pieces, and we can see fractions of those pieces here. So write your answers as fractions, and let's find the probability. The pointer stops on the following colors. So we can see that red over here takes up 1 section of the 12. So the probability would be 1 out of 12. Go ahead and figure out for me, and then come back and check in. What are the probabilities of the other 3 colors? So the probability of the blue would be 2 out of 12. Remember, it does ask us to find it in lower terms, so that's 1 out of 6. Green would be 5 out of 12. That is simplified. And the yellow would be whatever's remaining, 4 out of 12. And simplified down to 1 out of 3. All right, so it says complete the table below. Well, the probabilities, we've already written them down there. You can change them to percents to put them in the table. If you were going to do that, we know this 1 out of 12 we've seen a couple times today is 8.3%. The blue 1 out of 6, we've seen that a couple times today, 16.7%. The green, which is 5 out of 12, we've seen that once today. That's the 41.7%. Again, these are rounded. And the yellow is 1/3 or 33.3 repeating percent. Find the probability the pointer stops on either the blue or green. So we're including both of these possibilities here. Again, the inaccuracy of using the percents as opposed to the fractions, that's going to give us 58.4%. Find the probability it does not stop on the green region. So again, probability of not green is equal to the probability, or 100% minus the probability of green. And so that's going to be 100% minus the 41.7%. And that's going to give me 58.3%. All right, that's it for our work for today. Go ahead and flip on over to your alone time and complete your alone time.